everyone. How are you feeling at the end of this ZK Hack Montreal event? What a weekend, hey? Okay, we have to get ourselves set up. Yes. Oh, and it's there. Okay, cool. This event, everything about it was unexpected.
Yeah, for the history books.
Thank you so much to all of you for moving location with us midway through a hackathon. I don't know if that's ever been done before in the history of our space.
For us, it was a first.
For us, it was a first. Maybe just a thank you to the team that did this. I know we have a slide, but maybe just
please
do a little clap
for the team.
Everyone who moved, everyone over. And thank you for continuing with us, because we realized that was a bit of disruption also in your hacking time, but we have come out the other side with some amazing projects.
We did,
We're so excited. All right, just a quick note on what ZK Hack is.
Yeah, so as I hope you know by now, it's a hub for learning and building. So these hackathons are one of our many projects. So again, if you want to know more, which I hope you do by now, go to zkhack.dev to know more about all of our other projects, and also have the link to our Discord where most of the action happens online. So this is our Twitter account as well. Please follow us. We're sending weekly list of links. We're sending a lot of updates about our events as well. And yeah, we'll be checking out all the pictures you guys sent with the hashtag ZKHack and ZKHackMTL. But yeah, I hope you do the same. And yeah, keep an eye on our Twitter. X, sorry.
Just a note, we have a little bit of merch left. There's some maple syrup. There's some hockey pucks. There's some bags and some T-shirts. We actually have to clear out everything, I think, quickly after this presentation. So if you haven't yet grabbed something and you wanted to, please do it now. And feel free to take, 2 maple syrups, because we do seem to have quite a few of those.
All 5.
All right. We want to say thank you. Oh, yay, I'm glad. Good. Yes, please take this merch.
Go for it,
okay.
Go for it. Don't fight, though, please.
Yeah, I want to say we want to sort of thank our sponsors for making this possible. We cannot do this without our sponsors. Like, ZK Hack is a joint effort, absolutely. And we say sponsors there, but really it's partners for this kind of event.
Sure. So yeah, thank you very much to Polygon, our long-standing partners. So thank you, please. Applause for Polygon. I don't know where to sit, but thanks, guys.
Thank you to Risk Zero, one of our big top sponsors this time around. Thank you.
Thanks to our base sponsor, O1 Labs. Thanks, guys. Thanks to Gavelot as well. And Novanet. It was great having you all with us in Montreal.
Thank you to all of our community sponsors, Pluto, Aligned, Lambda Class, 1KX, Fenbushi Capital, ZK Verify, Aztec, and Celestia. Thank you guys for coming through. Media partners for this one were Dabble Club and EduDAO. Thank you for sharing that in your channels. And as mentioned, videos for this will be over on the Zero Knowledge Podcast YouTube channel, as well as the ZK Hack YouTube channel. And the prize partner is ZKV. And we're going to tell you a little bit more about them once we get to the final prizes. Yeah. Oh, yeah.
Yeah, go for it. Go for it.
Them, AKA us. Yeah. All right, so now we are at the end of our schedule. It's been an amazing weekend, truly memorable. The places we've gotten to be in, this is kind of amazing that this was our backup. This was like this is where we had to go after we were kicked out of the other beautiful venue. We're now in this beautiful venue. Yeah, and we have made it to the end. So we're going to be doing our winner announcements very shortly. I feel like I'm keeping the suspense going. Okay, but first we're actually going to be sharing, the sponsors are going to be sharing their bounty winners. So we're going to start with the top sponsors. I think Risk Zero's first.
Yes.
Yeah.
So yes, Risk Zero, please come on stage.
Thank you. Okay, so you guys, I can't tell you how impressed I am with what's come out of this community here. This is, I think, my favorite hackathon thus far, and that's saying something. I've been to a lot. So all of you, whether or not we gave you a prize, whether or not you worked with us, you did awesome. So applause for that. And now to give you some money. Bounties, we got a lot. Integrations. We have Ludex, ZK, Z-Tips, Drink ZK, Lemma, Zalo, ZK, and IGV Genomics. If you want something, shout out. Shout out. Woo. That's a lot of people. And a side note, we might have missed some folks. We're going to follow up with you afterwards. If you're not on this list, you might need to be. Come find me. ZK Coprocessor, Z Compose, Lemma, ZK Blackjack. Woo! Shout out. And the absolute best, Z Compose, provable multi-party delay encryption. Thank you all. You guys did good. I really hope that we can continue this journey together, whether or not you won something. We're going to be doing some awesome stuff in subsequent events for the rest of the year. We're looking at East San Francisco and stuff around DevCon TBD. So if you want to follow us, the Risk Zero Luma is the best place to be, and our Discord online will be able to connect and keep, well, I guess, learning and growing. All right, thanks, guys.
Thank you, Nuke. Thank you very much. Okay, now let's call Polygon. Yes, Blake on stage. Applause, please. Who is hungry?
All right. Yeah, sorry. I like to be tacky. Okay. Enough of the race car sounds. Yes. Wow. This has been an amazing experience here in Montreal. Excited to be back in Anna's town. So we actually had 2 really incredible submissions for Plonky 3, and so due to the low submission count on the other bounty, we kind of stole some of that money, and we have I can't read them, but oh, here we go. Yeah. We have, we're awarding $1,500 to 2 teams. So Plonky threesome, which is so funny, and provable multi-party delay encryption. So they both get 1,500 buckos for their amazing projects that they built. So give them a round of applause here. And yeah, we were very thrilled to, I think the presentations even allowed us to dive deeper into those submissions. And I'd just like to say that some of that feedback is going to go directly to Polygon Zero team, to the founding team that's actually building the Plonky 3 libraries, just based off some of that information that we got back. And unfortunately, there was a very low submission count for this one. It was a more challenging one. There was some people who maybe pivoted or just maybe didn't implement it the proper way, but we will carry on and the race will continue. So yeah, well, we look forward to the next ZK hack, and I think we'll always kind of bring some of those more challenging bounties here, just because it's really fascinating to see how creative people get with some of these hard challenges. So thank you again, everybody, for having us.
Thank you very much, Blake.
Your slides are amazing.
We're going to call O1 Labs on stage now to announce their bounty winners. Go for it.
Hi, everyone. Just before I announce the winners, before I announce the winners, just really quick, take a second to say thank you so much to Anna, to Gaylord, to the rest of the ZK Hack team. We've had so much fun. It's been really, really great. And also thank you to all the venue staff, the AV staff, everyone. So big round of applause for everyone, please. Okay. Which one? Thank you. I obviously don't present a lot. Okay, so we had lots and lots of fun with all of you hackers all weekend. These are the bounties that we ended up, or the prizes that we ended up giving out. So the first was our Living Proof Challenge, and we awarded a $2,000 bounty to a project called Supply Chain Finance Reimagined. Really cool project using the recursive nature of the Meta protocol to create evidence of good company standing using recursive ZK proofs. Really cool project, so well done. Thank you. And then for our second bounty, which was using our new off-chain state API, we awarded 2 bounties there. The first one was for Mina States, which was a really cool, well done, Saurav, a really cool implementation of a game you might know as Nation States. Got some really great feedback on our new API, and a really cool game there. So well done, Saurav. And then the last one was a $500 bounty for p-voting. Well done, Armando. This was a re-implementation of one of our private voting applications using that new API. Again, lots of great feedback on the new API and lots of great insights. So well done. Thank you.
Thank you. I think you have it. Gaylord, you have the clicker now. Here. Oh, if we can hear from here, Gavilod. I think that one's not working.
Hi guys, I'm not good at talking on stage. Thanks a lot for the organizers and all the participants. It was an amazing experience. We are awarding $500 to the Scroll Prover integration team, ZK's 2 team, that was the name. They've been working on a quite challenging challenge. But yeah, great job, and we're looking to continue working with you girls. Thanks.
Very cool. Thank you.
Thanks, Norbert. And now we are calling Novanet on stage for their bounty winners. Take your time, Wyatt.
Thank you. So just to thank our hosts once again. There was a big change right at the very beginning, which is probably very hard to deal with, but I think you guys did really good, and this event is very, very cool as well. With Novanet, we're dealing with portable ZK, so memory efficient zero knowledge proofs for 2 different things. One is verifiable compute on local devices, and the second is for privacy. If you give your data to a third party, it's obviously not private, so we want these things to be small and portable. So the very first prize is for a verifiably good attempt. They're doing provable multi-party delay for encryption. Make sure everyone gets the same start by doing this verifiable delay function. Congrats for 1,000K USDC. For the second one, privacy. There's a joke that there's ZKML and they're always like the Kool-Aid man. They like to butt into conversations and just run through the wall. We did have one privacy based on ZKML, and they're using Novanet to parallelize the proof across multiple devices. This is kind of like privacy, but it really depends on the model. It's cool because they use Rust Candle, which is a very portable way to do ML and AI models. It works in browsers. Novanet also works in browsers via WASM. So it's cool that they mix these 2 things together, portable AI with portable ZK. Congrats, 1,000 for you as well. The grand prize is definitely my favorite. We gave them the remainder of 3,000. They were working very hard the entire time, and it was actually very cool from the start. The industry they targeted is worth $230 billion. It's the ads industry, and they're using ZK on local devices via browsers. This is important because our stuff works with WASM, and the ZK engine also compiles onto WASM, so it can actually end up on users' devices very easily. It lets you find your customers without invading on their privacy, which I thought was a very cool use case. Yeah, $3,000 to you guys. Congratulations.
Nice.
Thank you very much, Wyatt.
Congrats to all these winners. So we also have our community sponsors who offered bounties. So we have ZK Safe Ownership Obfuscation, who got $1,000 USD from 1KX for that bounty.
Congrats.
Congratulations.
2 bounties for Pluto were claimed. So one for the SumCheck implementation with Hackathon for Ashtosh. Congrats. And $500 to Hector Massib for the HMLC implementation with hackathon. Congratulations.
For a Lions bounty, the winner was Zayalelo. Sorry, for 1,000 USD. Congrats.
Congratulations, guys.
I also can't see it. It's so small.
And ZK Verify awarded $1,000 to the Z-Gate projects. Congratulations, guys.
All right, so those were the bounties. Wowza. We are now entering the moment where we actually reveal the general prize winners. I want to invite Chloe from ZKV to the stage to help us out. Yeah. I wonder if we can get that mic on, the third mic. Let's see if they can make that.
Hello.
Okay? Okay, good.
Hi, everyone. I hope you've had an awesome weekend hacking. I was actually here in the venue at 3 a.m. and there were about 5 or 6 of you still going strong.
Whoa.
So extra points for hacking in the early hours of the night. So yeah, I'm Chloe. I work for ZKV. We are one of the proud prize sponsors for the prizes today. A little plug for those of you who don't know ZKV. Our mission is really to empower the teams building the next generation of distributed systems in order to transform the internet. And we actually do this in a number of ways. Firstly, we are a validator, so we validate on proof-of-stake blockchains. We're currently one of the top validators across Cosmos, Celestia, and Mina, and we operate on over 12 networks. Secondly, we are an investor and we back exceptional founders in the zero-knowledge community. And we host a portfolio of over 30 companies. And last but not least, we do a grants program for events like this where we really give back to the community. So we're really, really excited to be the prize sponsor today.
Yeah.
Thank you, Chloe.
I happen to be a co-founder of this company as well. I feel like I should disclose
Yeah,
this.
Anna is one of the co-founders of ZKV as well.
But I'm so glad you shared that with everyone. So we're starting.
Let's
Okay,
get
so
started.
maybe we should explain what chewing glass is again, just for anyone who
Yeah,
doesn't
go for
know.
it.
So this hackathon, because ZK is still sort of in the state it's in, we've noticed that there will always be submissions that are just like these deep technical implementations, like taking on a hard challenge, and they don't really fit in the general competition. So we've created a new category called chewing glass. And
the winner is... Oh, it's
winners?
a tie.
It's a tie.
Oh, what a
Couldn't
surprise.
choose.
So yes, we have 2 winners for the chewing glass prize. Sparta 0 and Plonky 3. Sam, congratulations to the 2 projects.
There was a lot of debate in the judges' room, kind of going back and forth, because both had just done exceptional things in different ways, and so we decided to split this one. Congrats to both teams.
Congrats, teams. Next is Hacker's Choice.
Oh yeah, so actually you may all know that, or unless it's flipping
Let's
around.
surprise now,
unless
that's
it's changed since we did it. But this is actually, yeah, this is the choice that you've made. So the winner is Pictionary Proof.
Congratulations, guys. So we're now moving to our top 3 winners.
All right.
Number
Coming
3.
in third place, we have
Zalileo.
Galileo.
I think I actually said that correctly.
All right. Second place, we have
Drink Z.
or Drakinskis. Yeah.
And ZK Hack Montreal grand winner is...
Lemma.
Emma!
Congratulations.
Congratulations! Ah, yeah.
And yeah, the grand winner, so the winning team, all 3 of you guys will have tickets to DEF CON 7 in Bangkok, courtesy of the DEF CON organization. So congratulations to you guys. You can buy your tickets to Bangkok now.
And just another mention of the ZKV team. So you'll be receiving your prizes from us on the ZKV side. Cool.
So before we move to the winner's presentation, thank you, Chloe. We want to say many thanks to the judges who
Yeah.
are judging you. So we had an amazing team of 15 judges. So please give it up for an amazing crew of judges.
Thank you for coming through to Montreal. Some of you flying through rain and sleet and being stuck at airports and coming early this morning despite delays. So yeah, thank you all for coming through. It was really fun doing the judging with you. And yeah, it's not easy doing this judging for hackathons like this. It's very different from other hackathons I've ever participated in. So thank you all for your time and your patience and also your great insights and for looking deeply into these projects. Thank you to the judges.
So we're now going to start our presentation with our winners because they have to catch a plane. So please, Lema team, come on stage for a short demo of your project.
Yeah, we're going to be hearing from the top winners. I think we're going to do top 3 plus Hacker's Choice.
No,
Or
we're
sorry,
going to do a chewing
top
glass.
3 plus Chewing Glass.
So yeah, 5
unfortunately,
presentation.
we will have to clear out, so I don't know if we can do all of them.
Go for it, guys.
And we're going to troubleshoot on the fly. So it's possible some of these things don't work.
Don't say that.
But they might work great. Also, does it work? Did it work? Does it work?
Let's wait.
Yep. There we go. Here, do you want a mic?
Yeah, definitely. Thank you so much. Yeah. You have another one you want?
Sure. All right. You guys
Ready?
I guess so.
All right, cool. Yeah, thank you, everybody. First off, this has been an awesome event. Thanks to everybody for putting it on, all the sponsors, all the judges. We've had a great time. Definitely some late nights, but have had a lot of fun and learned a lot as well. So we'll just jump into it. So we, over the weekend, built a project called Lemma, which is a ZK theorem proving framework that enables individuals to post unsolved theorem definitions accompanied by a bounty, essentially. And then users can submit, essentially, bounty claims with a valid solution to that unsolved theorem. And so it uses ZK to basically prove that this is a valid proof to this theorem. And then the user can then claim that bounty through this commit reveal scheme. So really the idea was to enable some sort of market where you could crowdsource solving difficult problems in a way that doesn't rely on any sort of intermediaries. So with that, I think we can get into the interesting parts if you want to jump in, Eric.
Cool. Yeah. So some of you may have heard of there's a programming language called Lean4, and it's like a rigorous sort of theorem proving framework. The idea is you have some sort of theorem. It could be, some crazy conjecture, and what you can do is you can sort of solidify that into code. And through a series of operations, then you can define your constraints and eventually prove rigorously that yes, your theorem holds, or no, this actually doesn't. So Lean4 is a language that some of our coworkers had some experience with, and we sort of had tangentially looked at before, but it was really cool and we wanted to give it a try. So we went to try and embed it into the RISC-0 ZK VM. And Lean4 is written in C++, and RISC-0 uses Rust. So it was a bit of a challenge. We originally started to do like FFI from Rust into C++. And because of a series of syscalls and basically some things that were kind of complicated, it maybe could eventually be done, but maybe not in a weekend. So we did end up pivoting to a different language. It's a protocol or a program called Proust. And it sort of does the same thing. It's a little bit simpler, but it's written 100% in Rust, and that is obviously incredibly useful for our purposes. So we were effectively able to embed this into the ZK VM. I'll really just quickly sort of show you the code here. So this is, like RISC-0 is so nice. You can really encapsulate everything into your guest program so quickly like this. So basically what we're doing is we have a sender, theorem, and solution as our inputs. And you can then append the solution to the theorem, put it inside the ZK VM, and then essentially Proust is going to be doing all of the parsing of the tokens that are in the input. It will then run to completion and say either this has completed successfully or it has not completed.
Okay.
Oh yeah, of course.
Go ahead. No. Yeah, we'll just jump right into the demo. So basically, we have the application live at lemma.market. And so Eric will basically demonstrate the process of creating a new unsolved theorem here. So you can enter in a theorem name. We have one prepared here.
Amazing. So we got a conjecture here that we're going to be putting in that's misspelled. I don't care. And so this is the Madeline, it's called, which is the code that's used to actually prove these theorems. We bounty amount, let's do 0.01 ETH. We're going to be a little bit cheap here, an exploitation time of like, let's say 4 days. So we're not giving people very much time. This may or may not work, we'll see. So you can submit your bounty. It'll go connect to your MetaMask account. Just confirm that. And you can see success. The theorem was successfully submitted. So it's basically just being submitted to the chain as a challenge.
Yeah, so there's really two main functions of a smart contract. Submit a challenge, or three rather. Submit a challenge, submit a proof to prove, hey, I have the solution, and to claim a bounty. So the next thing Eric will do is he'll go to the unsolved theorem, submit the proof.
There it is. You can see it's popped up, so we can click that. And just it so happens that I have the solution to this very complicated theorem right here in my notes. Shocker. We'll paste that in, and then we can go ahead and submit our proof. We'll see. Let's do a little reload. Oh, okay. So this is what happens when you don't pay for an API key and you try to use the free one.
Yeah.
Occasionally it stops working.
But this is the idea. I think the opportunity to basically open source or crowdsource solving interesting and unsolved problems in mathematics is really interesting in that you don't have to have like an intermediary to act as like, hey, yes, this is true, no, this isn't. So yeah, I think that's just about it.
Cool. Yeah, I did nothing else to add. Yeah. It's been really awesome getting to meet you guys and like hanging out, talking to everyone. Everyone's been so friendly, walking around and saying hi. So yeah,
thank you
spectacular.
So much.
Thank you.
It's been an awesome event. Yeah.
Thank you, guys.
Yeah.
Congratulations.
Amazing. I guess we'll go in that order. We'll go to second.
Yeah, we're going to call Drink KZ. I never know how to pronounce it.
Drink Z.
Please join us on
it's like
stage.
drink with a K, Z, like it's switched,
Yeah, Drink ZK, maybe, yeah.
Cool.
Okay, please join us on stage.
Nice. There you are.
I will neither confirm nor deny if any of us are drunk. Maybe outside of this venue. So we're drinks, or drink KZ, but drinks, that's better. So idea is simple. So what we wanted to do was to prove that somebody's drunk or sober, and we ended up building a breathalyzer. So because of kind of certain regulations around this venue, we can't show you the actual demo, but I'm happy to show you some of them outside of this venue. So kind of the problem we're trying to solve is really about data ownership and trust. And with the case of drinks, you can think about it in two cases. First is, hey, some cop gave me a DUI, but I wasn't drinking, and I did pass the breathalyzer test. And if you can prove that, hey, the moment that somebody did a breathalyzer test on you, that some data was collected and you weren't drunk, maybe you put it on chain and you can show it to people that this is, false accusation. That'll be interesting. Another case is, maybe you did fail the breathalyzer test, but you were like 15 or 16, and you don't want everybody in the world to know that, so you want to keep the information private. But if you're having an interview and somebody asks you, hey, I see in your record that you had a minor misconduct, what does this mean? Can you tell me about this? Now you have something to show that's credible, instead of having that person who's asking you think of something that's worse. So the process is simple, right? Because you just prove, like once the device is connected to your app, we just try to prove it. But I think I'll pass it to Harry to talk more about how it's actually all implemented.
Yeah, so let's talk about the architecture here. So we collect data from Raspberry Pi and send it to the app on the iPhone. And we calculate the data hash and send it to the Apple's app attestation service. So the important part is about this attestation service, because it can make sure that this app is running on a real iPhone device, and the app is not modified by the attacker. So after we get the signature from the attestation service, then we can use the ZK VM to prove the signature's validity. And then we can submit this signature and submit a signature proof and the sensor data on-chain, so that now we can have a trusted sensor data that we can use in a smart contract. So we do lots of verification in the ZKVM, for example, the certificate chain, because we want to validate it using the Apple's root certificate. And we also rehash some of the client's data and the public key and the app ID to make sure the data's integrity. So our demo is to mint an NFT after this data gets verified in a smart contract. So you can prove that you actually get this alcohol levels sensor data, and you can prove it on-chain to mint an NFT from it. So the technical significance here is that we are trying to solve the Oracle problem, because we want to trust the ZK proofs instead of the economic incentive, which is a major way to do it in Oracle nowadays. So the trust assumption of our application is, first we trust the Apple's root certificate and also the attestation service. Then we can have a programmable trust to the app's developer. So now I can say that in this smart contract, I will trust this app, or to what degree that I trust this app. And it's enabled by the attestation signature to make sure that this app cannot be tampered by the attacker to generate something, to generate some false claim. Yeah, so we're Drinksy. Thanks for listening.
This is Harry, Monica. Thank you.
Thank you for the presentation. Here, I'll just grab these. Yeah, we don't want them to fall off. Cool. All right, that was drinks. I think we'll do our third place winners.
Galileo.
Galileo.
Good,
I said it right that time.
Yeah, nicely done. Good. We have a USB-C dongle, yeah.
Very nice.
We got 3 mics. So.
Okay, so we've built Galileo. Problem that we found with existing ZK-approved location apps, this one, is that it assumes that the coordinates that you put into it have actually been verified or are correct in any way. It doesn't do any checking in terms of it just assumes that the GPS ordered coordinates are correct. But as some people here might know, it's quite easy to spoof GPS location, especially on an Android phone. It's a matter of downloading an app and changing the location and relaunching another app to consume that. So we've looked at that problem, and we started looking around at what solutions there could be. And we found that the Galileo satellite service, which has been launched by the European Space Agency, actually signs navigational messages using OS NMA, which is a standard that they developed. So we looked at that and decided to build a clone of the proof of location service and verify the signatures that were being, verify the signatures from Galileo navigational messages. So yeah, what does our app actually do? It verifies signed navigational messages, generates proof of location with risk 0, allows verification of the location within a certain radius, and then we've added the possibility of posting the proof posted the proof on chain with aligned layer. So we now have a short demo.
Okay, so the first part was to gather the data from the satellite. We used a fork. I mean, we forked the GNSS logger, which is an open source project from Google. What we did is then just simply log in the data, and that's pretty much it. And then
Yes, so let me demo you the application. I just need to share, to cast the screen of my phone on the computer. Yeah, it should work quite soon. Perfect. Okay, so this is the demo of the application. We are demoing it so you will have like a better idea of the product that we are aiming to build. So let's start. It's quite easy to understand. This red spot is our position, and I can just click on the screen to have another dot. And after this, I can just slide on the screen to increase the radius of the circle. And what I am going to prove is just that I am part of this radius without proving where I am exactly. So let's just generate the proof. It's going to take a few seconds. And once the proof is generated, you can simply verify it using ZK Verify or Allied in our case, which is quite fast, you will see. And that's it.
Thank you.
Sweet.
Okay.
Thank you. So those were our top 3 teams. Now we're going to hear from our chewing glass
So
folks.
we start with Plonky 3 Sam.
Let's start there, yes.
So yeah, Plonky 3 Sam, please come on stage. So that's the first winner of chewing glass. And we'll have our last presentation after. Please come on stage.
We'll see. Let's see.
This guy.
HDMI or no? No, I think it should. Oh, I just need to. Oh,
it looks like it worked.
Okay.
Yep.
Yeah, sure. I just don't know where is the mouse, so if I.
Here, it's down here too.
Okay, good. Am I on that screen or on this screen? Oh, I came here. It's good. Now I can do it, no? Okay. It seems to work. So sorry, it's much more boring. There's nothing, so exciting and sexy about it. But but there's a big motivation behind this protocol. So I will talk about the motivation, which is more exciting. So the goal here to aggregate public keys. Which sounds maybe a bit boring, but it has a lot of deep application. So the biggest application is for bridging between consensus systems. So if, for example, 1 million people sign something and you want to prove it on another blockchain or light clients, it's very, very hard to send, to tell them to add this, to give them all the 1 million signature or 1 million public keys. The solution is to aggregate the signature and aggregate public keys, and then you give one signature and one public key, and you give it to the other system and say, verify it. The problem here is that the aggregation, how can you believe me that the aggregation is correct if you haven't done the aggregation yourself? So the solution today is that I give you the aggregation, but also I give you a succinct proof of aggregation to you. This can be used in anonymous verifiable voting. So basically, you add your public key to some blinding factor, but you prove that in this aggregation, there's a specific public key from some committee. So you know the person was eligible to vote, but you don't know who is it between this committee that was eligible to vote, or which can be used for like single leader election. That you want to have a person selected, but you don't want to reveal it till that person perform his task. This is the original paper, but I did a few changes to that. So this paper is mostly on Planck. So now that I saw the Planck 3 with the air, that I moved it to air, and the other one is a different coordination system on elliptic curve. I needed it for a curve. It's called Bandersnatch, the curve that is used in Zcash, which use another coordination. So now I'm just going like in 30 seconds show you the math, which probably not very, very helpful. But anyway, so I wanted to work on Bandersnatch, but it was too big for all the field that Plunky was offering. So I went on a smaller field and searched for another twisted Edward curve. I found this one. You see at the bottom 2 to the power of 6 times a prime number, so it's almost like a cryptographic curve. I took that, and then I built this error table, and that is basically how the aggregation work. So BI, the BI says, the column BI basically says if the person has been part of the signing or was absent. If he signed it, then BI is 1, and if he didn't sign it, then it's 0. And so you start aggregating in the KAC, the accumulators column. So if the person has signed, you add it to that, but the addition happens on elliptic error. If it didn't sign it, then you just copy from the bottom, right? So you don't add to the public key. And then at the end of the table, you have to verify the accumulation of public key with that. So basically, so I used Plunky 3, and it was very, very fit for it because of the error that you can so easily implement in it. But I'm not going to bother you with codes. But thank you very much. Thank you for.
Thank you very much. And last but not least, we will call the Sparta Zero team on stage, tying for Chewing Glass Prize. Go ahead, guys. Oh, very Spartan.
Hey everyone, this is a presentation of Sparta Zero, which is a super Spartan IOP written in Rust. So Sparta Zero implements the Super Spartan protocol. It is a polynomial IOP for CCS instances. So basically the problem is that we want to prove that some CCS constraint holds. And our solution is to use a multivariate sum check to prove a single CCS instance. Quick background on SumCheck. So the SumCheck protocol seeks to prove that a claimed sum is in fact equal to what it says it is. And we do that by summing the evaluations of a multilinear polynomial over the Boolean inputs of a hypercube. And this is like a very famous algorithm in ZK. And if you talk to a lot of cryptographers, like this is the algorithm that where ZK really clicked for them. And I think for both of us during this hackathon, I think we both felt that very strongly. CCS is a relatively new constraint system. It is a generalization of R1CS, and it enables us to capture R1CS, Plancus, and air type constraints. Here you can see the actual equation for CCS. And down there, just note that the Z actually, that indicates the inputs of that constraint system. Quick walkthrough of the actual Super Spartan prover. It is a polynomial IOP, so interactive oracle proof, where we send a multivariate polynomial to a verifier. They respond with a random challenge, and then we run our sum check reduction multiple times on that challenge, on the multivariate polynomial. And then finally, our verifier checks multiple random points on that Boolean hypercube, and if they equal 0, then the sum check passes. So we're essentially doing like a progressive reduction of the problem, and it gets smaller and smaller and smaller, and we continually insert random elements until we know for sure that the sum is what it says it is. So John's going to talk through the implementation quickly.
Yeah, so over here you can see, so essentially, what we need to do for this is that like we need to implement the sumcheck protocol, and the sumcheck protocol mostly works in a multivariate polynomial. So essentially, what we did was that we were working on top of the hackathon repo and added our own implementation of a multivariate polynomial. And then with that, we implemented our own sumcheck protocol over here. So you can see it implemented over here. It's broken up into different steps. One for checking the sumcheck claim for doing the sum, and then for each round, we essentially prove the sumcheck, and then do some other pre-processing. And then we also have tests to verify this. Yeah. And then, yeah, over here, give me a sec. Yeah, so we have like a simple example where we converted the Fibonacci problem into the sumcheck problem, and then it will generate like a valid proof over here. Mm-hmm.
So that's it. Thank you for having us. Awesome hackathon. Can't wait for the next one.
Thank you so much.
Thank you, guys. Congrats again. So I think it wraps it up. Yeah, we want to say thanks.
Yeah, I think this is sort of now we've really reached the end. So big thanks to all of the volunteers, the AV crew who've been fantastic.
Thanks, guys.
Obviously, all of the hackers. Thank you for coming.
Congrats to you, yeah. You made it. Through
I want to say thanks to Lou and I for catering. I know you guys really liked that. There's some big fans. Thank you to all of our sponsors.
Thanks again. Give it up for our sponsors.
Big hand for all of the sponsors. Oh, good. Phew. I was worried we had forgotten the team slide. This is very important. Thank you to the entire team that put on ZK Hack Montreal. This was one of the most challenging ones we've ever done.
It was a
truly challenging. Agni, I mean, I think everyone here knows you're keeping this ship going even when it's actually being waterlogged and rained on and no power, and we still make it here. So thank you so much for pulling
well
through.
done.
Seriously. Gaylord, Quentin from the ZK Hack team, thank you for everything. Like, where's Quentin? Where are you?
Yeah,
thanks, there. Man. Yeah, thank you. Thank you to Natalia and Hanya. Hanya was managing all of the volunteers this time from the start. Yeah, thanks to everyone.
Thanks, Anna. Thanks to you, Anna, as well.
I think we don't have a slide for them, but like DevFolio, the tool we use, I mean, those guys behind the scenes are also working quite closely with us, so we should say thank you to them. They're almost part of the team, I feel.
That's true.
Yeah. Cool.
So yeah, what's next for us before we say goodbye? So keep an eye on us. Please stay on our Discord. That's where our study groups online happens. We have the Thala book. That's an ongoing study group. We will have soon a new study group on a new book. It's called the Snacks book. Maybe you're aware of it. It's co-written by Alessandro Chiesa and someone, I forgot the name.
Yeah, we also have, and this is sort of not quite fully announced, but I think we've mentioned it in passing, but we're actually working on a second season of the ZK Whiteboard sessions as we speak. There might even be
tomorrow.
There might even be some people here who might be in it. If you haven't seen the original ZK Whiteboard sessions, this is just an amazing way to onboard yourself into ZK. There's 19 modules published right now out there. You can just search ZK Whiteboard sessions, or you can find it on the ZK Hack website. And yeah, we're going to come back with a season 2.
Yes. So yeah, keep an eye on us also. We'll keep organizing ZK Hack IRL meetups. We've done in Lisbon, in London, in Athens, in Berlin, in Brussels. So yeah, keep an eye on our channels, and we will announce the next one soon.
Yeah, I think there may be one in Istanbul.
I don't know. Yeah, maybe. I've heard so.
And we also, so ZK Hack events. We have the hackathon, we have the meetups, these are our in-person events, but we do an online event, which is a multi-week event. This is actually where the original ZK Hack name comes from. It's planned right now for November 2024. Nothing's set, but we have a vision. So it'll probably be like 3-4 weeks of workshops online with a puzzle hacking competition.
ZK Hack 5.
ZK Hack 5, exactly. Where oh yeah, whoops. Did I put that in? Oh, sorry. There's supposed to be 5. So we're hitting ZK Hack 5, ZK Hack Online 5. Yeah, and there's going to be puzzle hacking competitions like kind of CTF-like, find the bug, win a prize, leaderboard. Yeah, it's going to be fun. And it's a fun thing to do from home, maybe. This is where you don't have to travel. We know you're already there, but in case you're not there, please go there.
I can still see fonts up. Make sure you join our Discord. This is the link. That's where the action will happen for the coming month.
Yeah. Also, just before we fully sign off, please check out Montreal. And check out Montreal, not this neighborhood of Montreal, but another neighborhood. The original venue, where it was situated, is a neighborhood that is very dear to my heart. I think it's a cool neighborhood, Smile End in Montreal. If you aren't flying out tonight, if you still have some time and you want to find somewhere to eat or something, I recommend you go back to that neighborhood, so where the original venue was, the Rialto, and then walk around there. It's quite a lot more, I don't know, it's more alive maybe than this neighborhood. Yeah, we're currently in I shouldn't totally trash it. We're in Old Montreal, which is kind of like a tourist part of town.
It's pretty too, but it's different. Yeah,
it's pretty but different. Yeah, so do check out the city. Yeah, if you've not been here before. And I think that's it.
That's a wrap.
Does that wrap us up? Thanks, everyone.
Thank you very much.
We made it. Rain or shine or blackouts or whatever, we got through it.
Thanks, guys.